almost finished up the first section and leading to the exercise 1. So we have 6 exercises. So we're kind of a little bit behind right now, but it's fine. So we will not have time for you to do all the exercise, but you can work on that after the workshop. But we want to cover some of the things we plan to cover here. And so one thing I want to point out, all the notebooks, all the source code available there, but if you also want like more comprehensive, I actually published the book 2 months ago. So on the Geemap website, if you want to access the book, there's a link there, book, and it should take you to the website. So this one gives you more comprehensive introduction to Geemap. So if you want to, but all the source code are available, so it's open access. So we can, just like the notebook that we are going through, all the stuff are in here. But this gives you a lot more content. If you want a hard copy or want a PDF, you can buy the link from there. But you can just go through the source code, download, and then try it out. So what we cover today, probably I would say maybe 10% of what's covered in the book. So if you want to learn more, welcome to check out the website. Next, let's go back to the notebook example. So I'm next going to show you the Earth Engine data catalog. And so earlier, we go online, go to data catalog, we get the ID, but sometimes you might have no idea where to get started, how to find the data, right? So here, Geemap has the functionality that allows you to search the data easily. So what you need to do is just create an empty map. And then upper left corner here, this is where you can search data. So kind of like going to the Netflix, search any movie you like, and then click and then play. You can do the same thing in here. So there's 3 tabs. Just click the data tabs. And then from there, you can search anything. So just like you're searching, going to the Google Engine website, here I can search, for example, let's say elevation or DM or whatever, okay? And then hit enter. It should be pretty responsive. And then, so on here, you see the list of available data set. And then you can select any one you like. So here, for example, I want the SRTM, right? So just click. And so you can scroll down. You can see similar to what you see on the Google Engine data catalog. The most important thing here to find out is the ID. So e.image, right? Just like what we did earlier, like the ID. So if you have the ID, you can just select that, copy, and then you can start doing the coding. But there's a shortcut here, import. Okay, so I would recommend just use this one, import, click, and it's going to show you this code block. So this is kind of similar to the JavaScript, but it has automatically converted to Python. So you don't have to. If you're using locally, it's automatically copied to your clipboard. But if you're on Jupyter, Google Colab, you need to select it. So you can just do it, for example, here, select this, and then Control C, okay? And then you can just, you can create a new code block, okay? Control V, you see? So now I have this map doc. And the only difference right now, this is using the old tradition, like uppercase map. You can change this just to lowercase, but we have not finished all the updating yet because it was a switch from like uppercase map doc add layer camel case to lowercase. So, but just let you know, you can do it. For example, you can just change to lowercase, the uppercase, and then just run it. You see, okay, load the data, and so all the source code JavaScript everything automatically converted to Python. So all the data set. The one that we're using here, right? I can just copy this one. I can just show you where it is on the documentation. Just Control V, paste, get to here. So basically it's coming from here. But you don't have to convert the code manually from JavaScript to Python. Everything has been automated. So what you can do is just search the data set you like, import, get the code snippet, run it, and then get the data set, right? So I can try another one. For example, here, I can come here, the data, I can search maybe lane cover, okay, hit enter, and then I can select whatever you like. You can scroll down, for example, let's say USGS Gap CONUS 2021, select it, oops, something lane cover, run it, and then I'm going to do it one more time, Gap CONUS, right? So you can see the ID, you can click the link. to take you to the Earth Engine website, or usually just click import, okay, and that's it. So, oops, select this, Control C, and I can come back to here, just pasting the code block. Again, I will fix that later, but right now just change the uppercase M to lowercase, and then run it. See? Right now, because of the visualization, we need to specify the color palette and other stuff, but just so you know, you can load any data. So this is kind of like you are searching the movie database, see what movie you like, just watch it, visualize it, that's it. So in that way, you don't have to go online to search the data catalog. So it's much faster. You can do everything within the Jupyter Notebook without leaving here. Right? And then you can do the visualization, you can add the data layer. So as simple as that. So this is useful if you don't know what data set you're going to use, you don't know like where to get started. Just search any keywords related to your to the things you want to study. Wildfire, elevation, land cover, temperature, you name it, anything you like. And then just take a look at the code snippet, run it, that's it. So the second way you can source data is using the datasets module. So Geemap has like this, make it available through the dot notation. So I can maybe import Geemap.dataset as data. So exactly what this one is doing is convert it to a kind of like a dictionary and then allow you to use the dot notation. So I can show you what this one is. So once you import the Geemap data, I can just type data dot, okay, and then hit tab. So what this one is doing is kind of like the entire data catalog is accessible through this kind of dot notation. Kind of like the movie, like all the movie database, and then dot, action movie, romantic movie, whatever, like the data provider. So in here, for example, I find something, let's say, what is USGS, whatever. You can just type a keyword, and then it will show you the list. You just go down and down until what level, right? So I can say, for example, I want the US, maybe NAS CDL or something like that, right? Select that, hit enter, and then you can run it, right? So this is easier because you only need to remember the first character of the data provider, and then you just tag it. You're going to convert this one to a string. So in that way, you don't need to remember this whole string. Otherwise, it's kind of challenging. I can never remember, like, for example, here, try another one, right? Dot Copernicus, something like that, right? It's the name going to be very, very long, right? You can just select it, cloud probability, hit enter, run it. So this is basically the string. It converted one to a string, and then you can pass into like image collection, the name, basically the string, right? It's up to you. But most of the time, if you already know what you want, you're welcome to go to the catalog, just grab the unique ID. This is only useful if you don't want to like remember and then copy and paste. You just import and then dot, you get the string. Kind of like in here, right? I run this one, image, and then data, right? Gaps, corners 2021. So this is essentially the same. I can just Control C here, Control V, just to show you it look like this. So I mean, the traditional way would be like this. Right? It's the same, except now it's accessible through the dot notation rather than you have to remember the string. So this is how it shows the data, either through the button, right, upper left corner, shows any data you like, import it, and then just run it, or use the dot notation. Questions? All right, simple, right? So after this, the entire data catalog, 100 petabytes is at your fingertips. Watch any movie you like for free for the whole like globe, right? So the entire data catalog like this, yeah, I'm not kidding, right? In geospatial domain, any data you like, anything up there, just search, run it, load it, good to go, right? You pay nothing. So what else can you like? What can you get? Like besides visualizing, you can. We are not getting into the computation yet. Right now, just simply watch it, and it's already like game changer. So in the past, you have to download like terabyte, but all the data is like petabyte. There's no way you can fit in your local storage. Not to mention like how to filter the data, how to do computation. Okay, So this one. So the next example I want to show you is how to convert JavaScript to Python. So for those of you already use JavaScript, you have something you want to convert into Python. Gmail has some functionality allow you to convert automatically. But I have to point out that it's not bulletproof. Okay, no, it cannot convert everything perfectly. If your script has some complicated like visualization, function nested, it's going to sometimes you have to manually do that. But if it is simple one, most likely you can do it automatically. So what you can do, just simply create an empty map, okay, and then thanks to the Google Sensing team now, like you can many of the documentation right now have JavaScript and Python. But in the old days, when I first got started in 2018, it was a pain, like because there's no Python example. You have to think about what you need to convert. So now, but if you go to the documentation, like just like I showed you earlier, image visualization, right? So nicely now you have the like code block like collab. You can open it directly, but not all the documentation right now has the Python example yet. So for those that don't have, just come here, copy, and then come to here. I want to use the uppercase, so make my life easier. It doesn't matter, but right now for the conversion, it's not using the latest one here. So I'm showing here. What you can do is just create an empty map, and then there's a button here, second row, second icon. Click it, and then just Control V, whatever script that you copy from documentation or your own script. Again, is don't panic if it doesn't work because it's not going to convert everything. It's two different languages. If it is just the API, you can do like automatic. But if it's like complicated stuff, it won't work. Then click the convert button. See? So now you have this converted automatically. Control C, Control V, and then come back to here, paste, right? Run it. See? So it's automatic, so you don't have to spend time like trying to do that manually. I can try out another example, right? So maybe go to spectral transform, for example, right? Yeah, nice. Usually the Python script, like there's no point to doing conversion, but I'm just showing you that you can do that. So again, I'm going to copy. How about this one? Okay, copy this one. Come back to here. Select, Control V, convert, Control C, and then I can replace this one. Paste. Right? How nice. So if you already JavaScript user, now you see, okay, this is pretty cool. Much easier than Python. Okay, I want to Python. Yeah, just copy paste and then see how it works. If it doesn't work, if you use any like doc chart or something, those right now do not have equivalent one, so it's not going to work. But most of the doc like image, feature collection, add layer, those basic stuff is supported, so it should be able to run it. Again, if it doesn't work, change to lowercase. I think I will update it. But right now, it's still using the old convention, map.add uppercase. But in the next release, I think we will change that. So you'll be m.add lowercase. So you should just copy and paste that. This is more like when I originally started developing Geemap. So I try to make it very similar to the JavaScript using the like uppercase and then like this. But now we are kind of more like trying to follow the Python convention. Is lowercase for variable name and then snake case for Python function names. Questions? Is it easy? All right, easy. So now we come to the exercise 1. I think here I was asked you to clip, but I forgot to mention one thing earlier is that you can clip click on image. Right now, most of the data, like for example here, is at a, this is not global scale, but for example here, I just want the data for San Francisco, right? You can clip it. It's simple as that. So I can come here, select whatever you like, okay? And then I just add a new code block. So how you clip an image? So there are two ways. You can clip to a geometry or you can clip to a feature collection. So what we are doing here right now, this is the, for example, the spectral. This is the image, right? So we can clip to this variable. So what you can do here, I can, oops, something wrong. So I can copy this one, Control C, and then come back to here, Control V. So you just dock, and then you just hit tab. You should show up the list of functions available, and then just type clip. Okay. So there are two ways. You can clip to a geometry, or you can clip to a feature collection. So the recommended way is to use the clip to collection. The clip to geometry is not recommended, but you can do it, right? Because earlier I just drew a geometry, and then now I can just clip. I'll show you here, and I can just m.user ROI, right? That one is a geometry. Then I can save this one to maybe, for example, subset 1. Okay. Oops. So this is a new image, right? It's already clipped. Then I can add the data layer to the map, right? So just like this one here. Add a new one. Oops. Control V. So this one will be subset. Don't worry if you cannot follow. It's just remember dot clip and that's it. So maybe img1, and then run it. Right? Oops. What is? Must be bounded to. Oh, I think it's not. Let me try it again. I think earlier when I Control C, I can cut the variable. So let me do it one more time here. Just hopefully it works this time. Image to clip. Interesting. Let me try image to clip to collection. This might be a bug, or it might be just something wrong. So clip to collection, and then m.user RIS. Yeah, this one works. So clip to collection basically means you can have multiple geometries as a collection. And let me turn the data layer off so they can see what's behind. Something is weird. Image 1. Let me take a look here. Image collection.
Are you referencing M below? I think you're using capital map.
M dot layer. Yeah, it should be.
Oh, never mind. Oh, you're using m.user ROIs. It should be capital.
Oh, capital M. Yeah, good point. Yeah. This is where sometimes it gets confusing. It should be M because I'm using the uppercase M. So this one should work now. You see? So it's clipped to the image. Good point. Yeah. So just be consistent. So this is where, so the recommended way is clip to collection, and then you pass in like multiple collections. So right now it's only one, right? So for example, okay, I want to do I want to clip to multiple. You can do that. So passing this one. So for example, this area, I want to have another one somewhere here. I can draw another rectangle. I can draw another rectangle. So it's up to you. You can as many as you want. So right now I have 3 rectangles. I can run this line again. It's clip and give you like 3 subset. So oops. And then you can turn it off. Take a look, right? And so after you're done, you can just clear the object. So you have 3 like multiple. So this is kind of the relevant to the exercise one, right? So earlier at the beginning, I showed you how to create a cloud-free mosaic, right? Using Sentinel-2, and then you get an image. All you need is image dot clip to collection, and then passing whatever Texas, right? I show you how to like filter, get California, get whatever you like, right? And then once you have these two, then you can create something like this. So this should be maximum 10 lines of code, right? And then you can just do it for anywhere. It doesn't have to be a state. It can be any country. So for example, select UK from the country feature collection, passing the collection to the image to clip to collection. Make sense? If you don't know how, you can work it after like after this. So in the workshop here, I provide the link. So the exercise. Of course, if you're already running on Google Colab, you can just type in, but I also put all the exercise all together. So in here, you can just type your code in here. We don't have time to wait for everyone. So if you maybe give you guys 5 minutes. So you can finish, raise your hand, and then we can continue. Because I have a lot more content to cover. So just think about what I said earlier. See if we can finish this one in 5 minutes. Like giving a data set, filter to the area, and then create a cloud free, and then clip to the area that you like, and then just display it. Okay. So right now it's 12:08. Wait until 12:13. And who can finish? If you need help, just raise your hand. I will copy the answer key later. Okay. Paste into the notebook so that you can trade it out if you want to. So just copy the example from the notebook they are provided, and then just change the name of the image collection. That's it. So it should be relatively straightforward. Don't worry if you have no idea where to get started. That's fine. This is not a test. There's no pass or fail. So just relax. You can always come back and digest it, and then you can do it again after the workshop. So the point of this one, this exercise, is that no matter what you want, so after this you should be able to figure out, get any imagery for your area, and then you can filter the data, kind of like teach you how to watch the movie that you want. So after that you should get whatever you want. You just need to know how to get the data, how to filter, and how to do some basic clipping, something like that. So whoever finished first, raise your hand. I'm going to give you a hug. Okay, anyone finish? Good job. I'll give you a hug after the workshop. I'll give you 1 more minute. Okay, thumbs up. Is it? 11:50. Oh yeah. So don't be frustrated. It's fine. I should give you more time, but we have more content to cover. So here, I'm going to show you what it looks like. Yeah, a little bit more than 10 lines of code, but most of the things you can simplify. So here we create a map, right? And then we're passing the US states, and then filter to whatever states you want. Let me copy this one here, just if you want to run it. Oops. You should be able to do it. So come here. So the notebook should be updated like automatically. So you can see here. And then, so this code block is pretty much the same that I used earlier for Sentinel-2 imagery. And then get the median, and then just clip to the collection, that's it. And then these are basically how you want to visualize that, right? So basically the same, just think about all the data in there is to narrow down and then get what you want based on the selection criteria, and then do some clipping, mosaicing, whatever, and then just add the data layer to the map. So this is the kind of a sample answer, but it's pretty much similar. So there's no really complicated data processing in here. Again, don't worry. You can click the link. I will paste all the answer keys later on. So when you open it, you should see these ones. Then you can just copy and paste and run it. All right. So this is for the first one, and I want to quickly go to other sections. So we only have like 15 minutes. Let me run it. So the next section is about visualizing data. So actually we have already been visualizing those data set. So the first one, this is in the core Geemap features, is the inspector, right? So you can just load the data layer. The only line of code that we change is the map.add, and then just passing the name of the tool. So in this case, you can so map.inspector. If you don't like it, you can just you can comment it out. The only thing you need to select the toolbar and then click this one, and then like this. So it should be the same. So you can inspect vector data, raster data, and by default, it's only showing you the raster data. But if you want to, for example, your focus is vector data, I can uncheck the box pixel and then check the object. So in that way, you automatically expand the result. So right now, if I click, for example, vector data, you see you don't need to click the plus sign to see it. It's automatically expand. So it depends on whether it's vector data, raster data, you can do it. So this is very useful because you want to maybe check the pixel values. So the inspector, you can access it through this one, or you can, if you want to edit specifically, explicitly, you just map.add data, add inspector, then it will show up automatically in here. So this might be useful if you are developing some interactive web app that you want other people to use. You can edit one directly on the map rather than, okay, go to the upper right corner, click this icon, and click that. You can just show it. Then user don't have to click anything. So you click your mouse on the map, you will show the attribute. So this is so-called inspector, is to get pixel values or even the vector data attribute. Next one is the plotting tool. So this can also be useful if you want to see the spectral signature. So for remote sensing, sometimes you want to see what it looks like. And again here, this is just one line of code. Right now, it's not very consistent yet. Like earlier, we used map.add inspector. This one is still the old way, so we haven't integrated it into the code yet. But you can add this using the plotter GUI, or if you don't want it, like do the same thing. Upper right corner here, the first row, second icon, that one is also the plotting. So if you click it, and it's going to show you the list of data layers, it comes from here. Okay, so whatever data layer that you have, you're going to show up on the list. And then from here, you can just click your mouse on the map. It should show you the plot. So this is kind of similar to the JavaScript code editor, right? So you can click anywhere, you can see the spectral signature. So if I click on the water, what do you expect to see? What does the line look like for water? Okay, don't click yet on your computer. Just answer my question first. Right, so if for remote sensing, right, what does the spectral signature look like for water features? Right, very low, right? And then it should be like going all the way down. I don't need to see it. I can imagine it, what it's going to look like. So this is like the spectral signature for, if you click vegetation, right, high reflectance in the near infrared. And that's why before the near infrared, like very high. And besides this, there's hyperspectral. So here, I can select the Hyperion, but you need to zoom in. So Hyperion has over 200 spectral bands. So if I click that, right, you see it's very dense. And this is also very useful, so I can maybe just click here, right? And you can see more like the electromagnetic spectrum, the reflectance. And so you can customize it. There's some way you can do. Here, I have 2 more lines at the bottom here, map.set plotting options. For example, I can want to add marker cluster, means when you click your point, it's going to add a marker. And also the plot type, I'm going to change to bar. So let me show you here. If I run this one, and then now if I come back, so for example, click this one. You see, it's going to change to the bar plot. So those things you can customize. We improve it in the future, but for now, oops, you see some of the things are not working expected. Let me run this one again. Sometimes it doesn't work, just recreate the code block and then run this one. So let me double check here. Run this one again, click, and then select Hyperion. Right, so you can see it add a marker, and then if we click somewhere else, yes, this is very similar, so it doesn't change much. You see, and then you can zoom out. It's going to cluster into a marker. Yes.
Does it calculate the pixels at the default the native resolution?
No, I think it's. I use a low resolution. I forgot what it is, like 10 times, or you can specify. I forgot. There's a e-doc like. The map, like this parameter you can specify. By default, this is more like for quick visualization. If you want to be very precise, we cover later using the zonal statistics. That one is the recommended way you can control the scale you want to use for computation. Because we don't want to be too slow, this one will be like low resolution, but it's more responsive. Okay, you can try it out, and hopefully in the future, I think we make it a little bit more fancy. Right now, it's very basic, but at least you can see it interactively. Next, legends. Okay, so let me run quickly this. Some of the built-in legends. For example, here I load the base map. I add the legend, right, upper right corner here. So it's very easy to add a legend in Geemap. You can use the built-in. So the built-in is some of these in here. For example, ESA, wall cover, Imagery, something like that. But you can customize if you want. So here, basically just one line of code, map.add legend. And then the built-in legend is the name, for example, NLCD from the list of the names. And then the max width and the height is like, sometimes you have a very long legend. It's very like overwhelming. You can specify a low height. So this is one. And this one is using the same thing, right? But this one using Google sensing data. The previous example is just using the base map, the wall WMS base map. So it's not Google sensing, but it's the same idea. So you can either use built-in one, or you can use custom one. So I'm going to show you this example. Again, it looks exactly the same, but the nice thing is that you can customize it, right? So it depends on whatever lane cover you use, right? So here, you can pass in a dictionary. So the dictionary is basically a key and the color, label and the color, right? So for example, open water, and this is the color. So it depends on how you want to customize it. If you don't like the text, for example, open water, I just want like water, then you just copy here, remove it, run it, you should get the same result. So pretty much this is a couple lines of code. This is so much easier than JavaScript. I'm not sure how many of you have tried to add a legend to JavaScript. It's one line of code is just a dictionary, add legend, right? 2 lines of code, you get it. JavaScript, like, I don't know how many lines, but you need to use a library, or you need your script will get very long. Just the simple basic one. So again, try to think in your mind, like when you're doing this, if you used to do it in JavaScript, how difficult it is. Now in Python, it's so much easier. Next one, color bar. So this is useful if you want to, for example, add some single band raster data, right? So this is elevation. It's nice, looks great, but even nicer if you have a color bar showing you the range of the color, right? So again, this is super easy. Just one line of code, m.add color bar, and then just passing the visualization parameters. So the color bar is going to create it based on the minimum, the maximum, and also the color palette. And you can have a label. So the label is what's showing up at the bottom here, like elevation, parentheses, or it can be temperature, right? Degree Celsius or wind speed, whatever. And just one line of code passing the visualization, and then the layer name. You want to use the same one as the layer that you use. So in that way, if you turn the layer off, the laser will also be off. So right now, for example, here, I go to the toolbar here, right? It's gone. So the color bar is tied to the layer. So in that way, you can turn it off and on. And I forgot to mention, right? You can change the opacity interactively here. And that's the nice thing about iPy leaflet and iPy widget. It's interactive. So this is one. Again, how many lines of code you need to write to add a color bar to JavaScript? And it doesn't look as crispy, nice like this. It's very pixelated. So this is horizontal. You can change it to vertical. I run a color block and then change to vertical. Even nicer. You don't like the color background, white color. Run it becomes transparent. Right? How nice it is. Right? One line of code, you can do a lot of cool stuff. And so Gmail under the hood write a lot of. This is like many lines of code actually for the source code. So it's open source. If you really want to contribute and improve, you can look at the source code and then contribute back to it. Okay. So this is the color bar. We have 5 more minutes, so we're going to go quickly a couple more features. Next one is the split map, and this is also very useful if you want to compare data layer side by side. Okay, so gmap.map, m.split map. Okay, so you create an empty map, you're going to add a split control on that, and you have passing to data layer. So the data layer can be a base map. So if you remember earlier, right, I showed you the button, see the name of the base map, you can pass in anything here, so left and right. For example, world topo map and then something else, so I can zoom in here, right? And then I can like, something like this. Right now, there's a bug, you cannot paint the map, so you cannot moving around, you can only zoom in and zoom out. There's a bug of iPy widget. It has been fixed, but it has not released to PyPA yet, but it should be fixed in the future. So if you can zoom in, zoom out, you can paint the map, right? You can see the data layer. And this is probably not very useful, it's just the base map. But you can just do the same thing for Earth Engine data layer. So you can compare to any Earth Engine data layer side by side. So what we're doing here is we're creating an empty map, and then we're pointing to an Earth Engine image, the lane cover. And so what you need is just this one line called gmap.ee tile layer. So this is pretty much the same as like m.add layer. The parameters are the same. So rather than add the data layer to the map directly, you are getting the tile layer. So just like the URL that I showed you earlier, and then passing, create this one is a variable, and then passing the variable to the split map. And so this one here, right now you're looking at Google Earth Engine data. So this is not base map. So I can zoom into here, hover your mouse. I hate that you cannot pan the map, but as you can see, right? Pretty cool. How many lines of code? How many lines of code to do that in JavaScript? Now it's basically a couple lines of code. You can create it easily. So you can compare, again, any data set, before and after, right? I can also do a link map. So this one doesn't work on Google Colab, okay? So you can run it. Don't try it. It's not going to work. So in here, and nice, right? I can move my mouse. So basically, if you sometimes you want to create multiple map views, you want to select side by side. This is 2 by 2. You can create as many as many rows, many columns. All you need is just here, gmap.link maps, and how many rows, how many columns, and then just passing a list of image collections. This is a little bit complicated, but it's the same image collection, but visualized using different band combination, right? So if you're studying specific feature, you want to see like which band combination is the best, you can do this, right? So you can also have a label, something like that, and so you can move around. Again, move one map doesn't move another map on Google Colab, so there's something, there's no easy fix. So if you want to try this one out using locally. 2 more minutes, so I'm going to show 2 more examples. Next is using the so-called inspector, time series inspector. So if you have a lot of images, you want to visualize side by side and also use this split map. This is pretty cool, right? So you can select, for example, an image collection. Basically, you construct an image collection, and then You just call the function TS inspector and then pass in the collection. So this case, we're using the same collection, one on the left, on the right, but it doesn't have to be the same. So you can have like length images, and then you can have lane cover classification. It doesn't have to be the same, but this is the same example. And then, for example, I can change, for example, I want to compare lane cover, for example, 2001 and 2019, right? So pretty easy, one line of code. You can change it. For example, when you compare 2016, right? You can see the changes, right? On the left side, it's being updated. You can do on the same thing on the right as well, right? And then you can do like this. How many lines of code? Not too many, right? The image collection, construct the image collection. Then one line of code. Give you an image collection, and then it's going to automatically construct this, right? How many lines of code need to write in JavaScript? And you can try it. I don't know. So next one, time slider. This is almost the last example to show you. So Geemap can help you visualize a lot of data. If you have like 5 or 6 data layers, 5 or 6 images, it's fine to add all the data layers to the map. But you have more than 10, you have 30, you have 100, it doesn't make sense to add all the data layers to the map because it's overwhelming. So in this case, you can use the time slider. Again, this one doesn't work properly on Google Colab because it's using multi-threading. So Google Colab has some issues, so it might crash. Just restart the runtime. If you want to try it, just use local one. So here, create a map, get the image collection, right? Whatever image collection, time series. This one is using the vegetation, NDVI. And then how we want to visualize that. And again, just one line of code. Add time slider. Give me the collection. How you want to visualize it. The time slider is like how many seconds you want to wait until you see the next one. And then it's going to add a lower right corner here, this time slider. You can drag it through. I'm not sure if you can see the changes, but so this one is 30 images, right? Every day, daily images. I add 30 images to the map, but it's not 30 data layers. It's just like one layer, but it changes depends on the time slider. And then I can click the button, just to play it. Of course, it's retrieving the data layer on the fly, so there's like not perfect, just like an animation. It's going to be some time lag, but at least you have, for example, you have 100 images. You want to see it quickly, just get the image collection and then just pass in map.add time slider, and then you can do it easily. So this is vegetation. You can do it, for example, for temperature, right? So temperature, 24 hours. And again, you can just temp the slider, change it. This gets a little bit more complicated. The source code is a bit longer, but you can digest it or just ask ChatGPT. It's really to explain to you. Or ask me when I'm here, but those are should be pretty straightforward. There's not like very complicated. And last one here, visualizing Sentinel-2 images, right? So if you're doing research for a specific area, and then you create a filtering. So for example here, I'm interested in studying the San Francisco, right? I want to use Sentinel-2 images. I want to use all available images. I want to use images that cloud cover less than 5% or whatever. So think about here, this is image collection, right? So now by now you should know how to get the data for your area. And I don't know how many images in there. I can just maybe collection. Let me add a new code block, right? Dot size. And 99 images, right? Do you want to add 99 images to the map all at once? Of course you can. Good luck. It's going to be very laggy. The list, like layer manager, is going to be very, very long. So you don't want to do that. But you can use the time slider. So here, right, very simple. Just how you want to visualize that. Just like when you map.add layer, the same parameters, and then just one line of code. Give me the image collection. How you want to visualize that. And then look at like this, 99 images. And then the time slider here, there's a timestamp for the images, right? Okay, starting from 2018. I want to see maybe the next one. Okay, 2021, September 21st. It's not going to be exactly the same because there's on the time the images. But now you're seeing all the images you like for a specific area, for a specific timestamp. You can filter it, like the cover is too much. You can just change the smaller one, right? For example, percent number 5%. Rerun it. And then you can see how many images. So this makes so much easier for you to query the data you want and then also see the data you want. Again, this is only touch 0.01% of Google sensing. We are only doing visualization. We have not really done any analysis yet. But at least right now, like the entire 99 A 100 petabyte catalog is at your fingertips. All you need is just figure out, oh, where do I want? I want it for this area, this lane cover, cloud cover, and then get a subset. And then Geemap can just one line of code help you visualize that easily, so that you don't have to make all the data layers. Like so here, like you can change it. So the latest one right now, for example, 2023, October 6th, right? It's 3 days ago. You have the image, right? You don't have to download. Is it like easy? Right, just follow the example and adapt to your area. And so we are out of time. We cover more later, but right now we cover like 2 exercises. We have a couple more, so we come have a break until 1:30, and then we come back, and yeah, then we start getting into real power, like doing analysis. Just like right now, we're just watching a movie, but how do you analyze how many times that character appear in a movie? How do you extract the character out of that movie, right? That's even cooler. So I'll see you at 1:30, and enjoy your lunch. If you have any questions, I'm happy to answer your questions. Okay, see you.